So today, we're gonna learn binary search. What is binary search? Well, binary search is a searching algorithm that takes advantage of the sorted property of the input array. It runs in logarithmic time, which is super fast even in large input arrays. If you don't understand yet, don't worry because we will have a visualization about this. Consider this example. We have a function called binary search. In the parameter, it will take a sorted array, start index, end index, and finally the item we are searching for. Consider this input, which is a sorted array. We will try to search for 25. The algorithm goes like this. First, look for the middle element in the array. If it is equal to the item we are searching for, then we can just return its index. But in our case, 25 is not equal to the middle element, which is 20. So now, we will compare the item if it is less or greater than the middle element. If it is less, then we can conclude that the item we are looking for is somewhere in the left part of the array. So we can now ignore the middle and just focus on the left side of the array. But in our case, 25 is greater than the middle element, which is 20. Since the array is sorted, we can conclude that 25 is somewhere in the right side of the array. And now, we can ignore the middle element as well as the left side of the array and focus on the right side. Now, do the same process. Check for the middle element. If it is the item we are searching for, then we can just return the index. So why is it called binary search? Well, binary means 2. In the algorithm, we divide the array in 2 parts, the left part and the right part. Depending on the value of the item we are looking for and the middle element, if it is less, then we will go to the left and ignore the right part. And again, do the same process. Divide the array into 2 parts. Then depending on the value of the elements, ignore the other half. Do the same process, divide it by 2, ignore the other half, until we find the item we are looking for. So now, let's have a comparison between linear search and binary search. So here, I have a visualization tool that illustrates the difference between linear search and binary search. Through this visualization tool, we can understand further how much faster binary search is than linear search. So now, try to look for 25. And I want you to observe the behavior of the 2 algorithms. Let's click on search. As you can see, linear search is still running, while binary search is already finished. Binary search only takes 6 steps to find the item, and it found it at index 33. Let's wait for the linear search. And now, linear search has found the item 25 in 42 steps. Now, we can further understand that binary search is much faster than linear search. Binary search took 6 steps, while linear search took 42 steps. So why is it so much faster? Well, in the linear search, the algorithm checks every element in the array from the beginning until it finds the item we are searching for. While in binary search, it first looks for the middle element and then goes in the middle of the left side, and then depending on the value of the middle elements, it will ignore other halves. Let's take a look again in the animation. Again, focus on the binary search animation. As you notice, it ignores other half of the array. So now we have understand what is binary search and how fast it is. Now we can write the actual algorithm. In this example, we will use C++ to demonstrate how the algorithm works. So now we will write the actual algorithm. First, the return value of the algorithm depends on you. In our example, we will return the index. So we will just make an integer returning function. Then write the name of the algorithm, which is binary search. Then in the parameter, we can pass now an integer array, which is a sorted array, and the start index, the end index, and finally the item we are looking for, which is an integer. The first thing we have to make sure is we are searching in a valid array. So how does an array becomes invalid? For example, we have this array A, B, C. Then the indices of these are from 0, 1, and 2. If the starting index is less or equal than the end index, then it is a valid array. For example, we have this one element. The start is 0, the end is also 0. This is also a valid array. So, if the start index becomes greater, let's say for example 1, and then here becomes 2, this is an invalid, or 0, this is an invalid array. So we have to make sure of this. So it is called the base case because we are gonna use recursive algorithm in this function. So we can say if the starting index becomes greater than the end index, then we can just return -1, meaning we have not found the element, or the array input array is invalid. So now we can start the actual algorithm. First, let's calculate the middle index. So the middle index is just the sum of the starting index and the end index divided by 2. So let's understand how it works. So let's say the indices are 0, 1, and 2. Just add 0 plus 2, which is 2. Then divided by 2 is 1. So 0 plus 2 is equal to 2 divided by 2 is equal to 1. So our middle element is 1. But what if we have more than 3 elements, and we are just doing a binary search on the right side? So how do we know the middle element? It's just the same. Add the first index, which is 3, plus the last index, which is 7, and that's gonna be 10. Then divided by 2 is gonna be 5. So the middle element is 5, or middle index is 5. So there it is, 5. Alright, and then let's get the middle element. So mid element is gonna be the sorted array at the middle index. Then now we will check if the item we are looking for is equal to the middle element. Then we have found the array, or the element. We can just return the middle index. But if item we are looking for is less than the middle element, meaning we have to make a binary search on the left part and ignore the right side. So how do we do that? We will just return binary search. This is a recursive call to the same function, or to the function itself. let's pass the same sorted array. Then we will pass the new start and index. In this case, since we are searching on the left part, let's pass the start index and then the middle index -1 because we ignore the middle index and -1 because we are trying to search on the left part, and then pass in the same search item and that will return the answer. Otherwise, if the item is greater than the middle element, we can just return binary search sorted array and we will start the middle index +1. So why I add 1 here? I add 1 because we ignore the middle element or the middle index. Add 1 because we are searching on the right side. Alright, I hope you understand this. And it will search up to the end index and then pass in the same search array. Alright, so let me test this algorithm. So let's create a sorted array. Let's say sorted equals an array. Let's say 12, 13, 14, 15, 20, 45, then 67. So let us try to look at this. So we call binary search. Then we will pass the sorted and then pass in the first or the starting index, which is 0, and then the end index is 0, 1, 2, 3, 4, 5. So we have 5 here, and then we are trying to look for 45. Let's store this in a variable called index, or just result. Result. Alright, and then we can just output the result. So here we should get, I think, 0, 0, 1, 2, 3, 4. So I think we should get 4 right here. So let's run the code, run code. Alright, so we get 4 right here, as you can see. So we get 4, alright. So let's try to look for 67. Let's see what we will get. So we have 5. So let's check 0, 1, 2, 3, 4, 5. Let's try to look for 13. Run code. Alright, it gives us 21. Alright, so the algorithm is working for now, and I don't see any mistake right here for now. And yeah, another thing is, if you want to imagine or count how many times it took until it found the search item, you can output on the screen the middle element or the index. Depends upon you how many times it checks. So let's try to run this. Let's find 45 again. Run code. And yeah, so first it checks 2. Does that the second index, which is 0, 1, 2. Then it goes here 4. Then it outputs the result. That concludes the binary search algorithm. I hope you learned something and understand how this searching algorithm works. And if you like this video, please like and share, subscribe to the channel if you want. And yeah, that's pretty much it.